looking at the notes for what if you are given a graph and you're asked to make or find its equation based off of just these 3 points. And at first you might be going, oh great, that's not a lot of information. But if you actually look at mostly this one here, your vertex, and the information you can get from your rightmost point, then you can figure out all your pieces to plug into the traditional graph function. So let's start with the vertex. The vertex is actually my h and my k. So right off the bat, I know that h equals 2 and k equals 1. So I'm basically halfway finished. So let's look at my rightmost point. So a 5, so that means I've traveled 5 over. Now h indicates your horizontal shift of 2. My rightmost point is 5. And so the question is, what did you have to add to h to get 5? And that is going to be our run, which is the same thing as our b. So h plus b should add up to equal 5. So my run is going to be 3. So now I can use my rightmost point and k. Now k indicates the rise or fall of a graph, as does the rise or fall of the slope. Tells you how much to go up or down from there to get to your next point. So if my k indicates go up 1, and then this says after applying my a, I ended up 3. So a must have been 2. So count up 2 over 3, there's my b, my vertex has my h and my k, and automatically I have all 4 points for my graph. So now I can just start plugging them in to my formula. And I'm finished. So all I used was my vertex, I used my right reference point to figure out my a and my b, and went from there. So this part here is an essential bit of notes that you want to make sure you have copied down. The rightmost point, the x of the rightmost point is going to be equivalent to the sum of h and b. The y of the rightmost point is going to be equivalent to the value of a and k. So these you can set equal to the rightmost point, plug in what you do know, solve for the other one. Same thing here, is that if I know how much h is, I know how much x they should add up to equal, then I can just subtract to find my b, which is what I did. Okay, so the vertex, this is all the information that we can get from this graph here. The vertex is at 2, 1, which means my line of symmetry is also at 2, 1. And there's the math behind the rightmost point. So let's talk domain and range. So domain is basically the same thing as demand, which is our little x value here. You can put a little head on him and you get a little stick figure man and runs back and forth. And so the question is, are there any values of x that do not fall on this graph that I can't plug in and get a y out of? So if I pick -1, I get a y of 3. If I pick -10, I'm going to get some y up here. So are all values of x, as I move from left to right, is there at least one value of x on this graph? And the answer is yes. It's all real numbers. From -infinity to positive infinity is all real numbers. My y, on the other hand, since a is positive, y is going to be greater than k If you remember, K determines the rise and fall of the graph, so it indicates what values of Y start the graph and either go up in this situation or later go down. So if I pick a Y, I can come over and hit the graph at one point to the next. If I pick 1. If I pick 2, I can actually hit the graph at 2 places. If I hit 3, a Y value of 3, here's 3 and here's 3. They both have a point on the graph. I can go on forever above 1. But if I pick a value of Y for -2, I miss the graph. It's not there. So as long as Y is greater than or equal to the value of K, then that is what the range is going to be. So let's look at another example for you to copy down. So again, we have our bits of information that you can have. Our H and our K was our vertex. Figured out. We said, well, there is our rightmost point. So our rightmost point, we went over and down 1, over 3 and down 1. So my B and my 1. And plugged them in to get my equation. Again, the range is going to be set by K. And since it's negative, my range is all quantities below K, because my graph is going negative. Domain is all real numbers, because no matter what, there's still a value of X. I can do X5, X8, X10. They're all values that count. So let's look at our last example for your notes. If I have this one here, again, here's my vertex. So there's my H, there's my K automatically. My rightmost point is -2. So what do you have to add to -4 to get -2? 2. And that's my B. My Y is at 2 and goes to 5. So what do you have to add to that? You get 3. So that's my A. I have all my values. I know my vertex and my line of symmetry. And so I can plug them in. Domain is always going to be all real numbers on these types of absolute values. As long as it's going and looking like this or like this, then it's all real numbers for domain. If the graph turns onto its side, then that's going to change the X. My range is set by my K, which is 2. The graph is positive, so it's going up. So all quantities above, or greater than, should I say, or equal to 2, you'll find any value of Y then on the graph. All right, have these notes. They'll help you decipher some of the problems, and I hope this helped.